Hello and welcome back everyone to Space Simulation Toolkit, where we are going to be doing our largest simulation yet on planet scale physics, which is really exciting because last time we put together all of the pieces of the puzzle. I think that we can make a hyper-realistic Earth simulation with tectonic plate shifting, maybe even getting crazier than that. But we're going to do it all today by merging all the things we learned, and I'm going to explain so you can figure it out too. Alright, so step one is that we discovered that it is easiest to pull this off when we make modifications to lava to make it have a little bit of buoyancy. So the trick is to reduce the amount of mass or effective gravity on the lava. And if you make it negative, you can actually push it a little bit further. But if you're going negative, you want to make sure that the lava doesn't fly out forever. So what we do is we go over to scene, go over to the sky, and then we turn down the temperature of the world, which is temp H, which means that everything's going to cool down really quickly now in the world. So you'll notice that the lava that we have here is just cooling down. It's becoming less and less red, and we want this effect to be really strong. So I'm gonna kick this temperature super low. It still seems to be taking too long. It's interesting that the bottom of this is still warm and the top is cold. I don't know what's causing this. It's actually very interesting. This is cooling down, right? Yeah. Huh. Yeah, the top's at like -200, and down here is at like... Oh, I know why. Because I'm pretty sure temp H is the amount that it goes down based on height, isn't it? That's why it's called H. You know, that would make a lot more sense if I've been misconstruing what that means. Let's try turning temp 0 down. Oh, that's probably what it is at the bottom. Oh, wow, okay, yeah. So this is starting to make sense now. Spike Viper is just a little dumb. Oh, wow, yeah, that's great. There we go. So that's what it is. Temp H is cooler the higher up you go, which simulates like mountains if you got your gravity on the bottom, but we're cool. We don't do gravity on the bottom. We do gravity in the center. We do planets. All right, grab that max stuck. Where is it? Where is it? There it is. And I'm gonna turn that really low. All right, so now things are moving. Things are moving and things are grooving. But there's one final thing we have to do to really get this simulation moving, and that is going ahead and grabbing our... Come on. What? Why is it giving me trouble? Come on. What on earth? Selected it. It's just not putting the window in the right place. Please? There we go. Our material lava. Now, material lava, we're going to go over to the gravity, and we are going to make it really low. And actually, I'm going to make it negative. Yes, a little bit unrealistic to make the gravity negative, but it's totally worth it because we get these awesome effects. So now we have the magma, which is being pushed out of the core. Now it's too cold. It's actually too cold. We need to increase the temperature of the universe a little bit because at this temperature, we are not going to get any progress. We may be able to get away with just having it be super low gravity instead of negative because the density and the amount of force on the stone coming in should still technically make it possible for the lava to escape. But we're doing whatever looks best. I don't care. It's not really about realism. It's about making it look awesome, all right? There's a balance to be had. Now we got tiny bit of movement. It's still just not quite there. I wonder if I should add a little bit more force to the core. just a little bit more energy. See if we can get it to... Oh, it's kind of... Actually, the core is actually kind of becoming molten. It's kind of happening. As long as this bubble here doesn't, like, immediately escape, we may actually have the effect I'm looking for now. I feel like this bubble is going to escape. All right, let's see what happens. It looks like a molten core is forming. It looks like it. As long as this giant bubble doesn't fly all the way off, I'm hoping that it grows and kind of forms a circle. And then off of that, we'll get what I'm looking for. But at the very least, when this hardens, which it's happening, it's going to make kind of like a big solid object instead of, you know, the really broken up stone. So at the very least, it's better. It's building actual, like, big chunks of stone instead of building these, like, nasty bits of sand. And occasionally, it may still breach to the surface, which I think is going to happen here. But yeah, this is much better. This is going much more how I want it to, so I may actually push it a little bit further. There we go. I'm going to turn the negative gravity down even further, which is going to make these eruptions a lot rarer, but I think it's going to make the entire simulation a lot better. There we go. Here's an eruption. 3, 2, 1. Whoosh. Oh my god. Huge, huge eruption there. Wow. Look at all the metal that got just thrown out here. That's crazy. It's really crazy. And then the second thing we're going to do is we're going to add a little bit more water. A little bit more water. And I'm going to add more water to this side too, because this side is just kind of not having any water. All right, and then I'm gonna add a tiny bit of biological material. Now, the bio should become dirt when it dies, and it should be able to grow in the water. So we're gonna see if we can support life with this planet. I mean, it might. It might work. Might not work, but it might work. I think we can make it a little bit larger. Oh, here we go. This is gonna be a huge eruption. Oh boy. And since we're still getting these, that means we can turn the gravity, the negative gravity on the lava, we can turn down even further. Oh man, this is going to be huge. This is going to be massive. Look at it pushing that huge chunk of land. It's actually cooling down. I don't know if any lava is actually going to escape, but it's definitely shifting the landscape. Oh, some is. Here we go. Yeah, we're getting some escape. Melting. It's good. It's good because it's actually going out. It's heating up the surface and it's melting that ice. Hopefully the lava doesn't touch and kill the plant. The plant's all being pushed. There's a tsunami. We got a tsunami occurring now. Wow. Wow, that super heated material coming in. We got the ice forming, and then at the same time, this heated material melting the ice. Oh no, the plant! The plant! I think the plant might be kind of doomed. Oh well, see what happens. This is going to be absolutely massive. It's probably going to be very ridiculous. Any second now. Any second now. Oh boy. No, it's completely frozen. Ah. Oh well. Happens sometimes. It happens sometimes. Wow, yeah, that's huge. Way to go. The core, that's basically like the entire core just left. Just got ejected all at once. It's just so satisfying. So satisfying to watch. This is so hot, I don't know if it'll ever cool down. It's probably going to get stuck like all this material, which is just beginning to cool down and fall back. Now I'm going to do something. I'm actually going to shrink this. Because even though it's cool to say there's a lot of mass and a lot of particles, I actually think we may get a way better simulation by just shrinking the whole thing. Part of the issue is that the core is only able to heat like a small area at once. I think if we shrink this, that we can get better results, especially when it comes to the water and life. So yeah, I'm gonna shrink it and I'm gonna see what happens. I'm gonna cover it in ice again. Give it some nice global oceans. Big simulations are cool, but sometimes it's just goes against making the simulation good. So yeah, balance the size of the simulation with, you know, the results of the simulation. So I think this right here is peak. Beautiful. That is a good eruption. That wasn't like insane in size. It's cooling down pretty quickly to fall back down. That was good. That was good. I think we're getting to a place of balance. And that's really what simulations are about. They're about finding the right balance. And there's also some other cool things we can do at this scale. Like, for example, I think we can give the planet a spin. Yeah. Yeah, we can. Giving the planet a spin gives us another variable, especially with the core heating, that I think is going to make things very interesting. But I think overall this is going in the right direction. I'm starting to see actual plates forming. Like even this, it's a little broken at the end, but it's still connected. It's still more connected than before. And the sand is actually going in. The sand is getting sucked in and getting turned into proper planet. So if this continues and the water finds its way back to the surface, then we may actually get the results I'm looking for. Look at that. Wee. I mean, we're going to continue to get occasional volcanoes, which is good. We actually want that. I'm very happy with this. I'm very pleasantly surprised with this. Honestly, I could watch it for hours. I'm really happy with how this has turned out. Of course, I wish I could get an actual ocean on the thing. Either the water boils away or it just freezes. But I guess that's kind of realistic. It's really hard to get a planet in the Goldilocks zone where you get that liquid water. I'm going to try adding more water. More water means more chance of ocean, generally speaking. Because the hot bits of the planet should melt it, and then the water will act as one big system that moves the heat around the surface, maybe. It should also calm down the volcanic eruptions. Keep them from being quite as ridiculous. What is the mass of water in this? That's a good question. It's 0.3, and then stone's mass is 4. Then what is ice? It's the mass of ice. It should also be 0.3, right? Yeah. Technically, it should actually be a tiny bit less than water because ice is less dense than water, but that all seems fine to me. I could make the rock a little bit more dense so that the water pops to the top more easily. Or I could make water less dense. Another huge, huge eruption. Oh! This over here is actually cooling down to the point where it's just becoming stone. Nice. That gives us a nice solid core, actually. I like to see it. The core is actually shifting now. It's shifting really heavily. That was a really strong shift. And now this material, some of this material is 5,000 degrees. The stuff hitting the surface is in the thousands. This is going to be a big one. Whoa. It's going to fly out to never be seen again. Alright, I'm going to try something a little bit different to see if I can make this still work. I'm going to actually turn the gravity on lava to be positive again. Just very, very low. So that this stuff actually does come back eventually. Now, you may be thinking, well, isn't that going to cause this to have huge problems? It might. Because it won't be escaping quite as easily. But I may just increase the... mass of stone to balance it out. We'll see what happens. But we're still getting lava streaming out. So let's just see what happens. Because I like it more like this, where it actually comes back down. It flying off into space is just a little bit unrealistic for me. And even though that's kind of the strategy we've been using so far. Wow, did you notice the planet actually gave itself a spin? It's actually spinning now. Not all of it, but it is actually spinning now. And now this lava's all falling back down. We're gonna see what happens. I don't know, it's still ejecting the lava. It hasn't completely ruined the effect, so let's just see what happens. I think it's gonna help form a more solid surface, though, which is good. That's what I want. Let it go. Whee! I can't believe it started spinning. So now that the lava actually falls, we can turn temp 0 up even further. And look! The water near the surface. It's happening. The glaciers are being ripped apart, actually. Look at that. This glacier right here is about to be torn in half. The Ice Age is ending. The glaciers are moving. Oh, wow. Look at that. Holy moly, that's a big one. Guys, I may have gone a little bit too far with the mass of the stone. It's getting a little bit more heated than I had anticipated. I think it's just because the heat was held in for so long. Oh no. Oh no. Mass extinction event. Ugh, I hate it when I cause mass extinction events. I think it's gonna be fine. Although, it is a lot harder for things to cool down now, and it looks like it is a lot easier for them to heat up now. Perhaps the core is too powerful. Half of the planet is now molten. Should I do something, or should I just wait? That is the question. I'm gonna wait. You guys keep telling me to wait, stop changing things and fast forwarding, just let it run its course, so I'm gonna let this run its course. But I think the planet may actually be falling apart. I think I may have gone too far. Man, the icebergs are just like, yo, what's up, man? Just sliding across the surface, running away from the lava. Oof. All the water vapor, all of my water is just being vaporized. It's all leaving. Yeah, I think all of the excess energy in the center of the planet has now kind of been released, because we were just letting it build up in there for a couple of minutes. I may have to turn the ambient temperature down lower. I think that might be a good idea at this point. Oh yeah, I'm gonna do two things. I'm gonna turn the massive stone down a little bit, because this is a little bit too extreme. I think you guys can agree. And then I'm also going to turn the ambient temperature down lower, because clearly it's a little bit too hot in here. And not just because I'm on the video. Oh yeah, there we go. It's calming down. It's calming down a little bit now. I just don't want the entire planet to be lava. I guess I can try to cool it down with water as well. I'll just, or actually ice. I'll just dump ice on it. I can't. Have I hit the particle limit? I may have. Oh! A little bit of a cleanup there. No, I didn't hit the particle limit. Why can't I draw ice? I guess I'll just draw water. Whoosh. It's gonna be a real rainstorm. And I really mean it. There's a lot of rain. Will that cool it down? Nope. No, it won't. Ice is still okay, yeah, this temp 0 needs to be higher. That's ridiculous if it can form ice, even though it's literally like touching lava. Alright guys, this has been a literal hour, so we're gonna leave it here. But we made a lot of progress today. I think we've learned a lot more about the variables and just messing around with things in Space Simulation Toolkit. So, if you enjoyed this, please leave a like, subscribe, leave a comment down below on what you want to see next. And I will see you all next time. Peace out. We'll save this one as Bean Planet. It'll all make sense eventually. Eventually. Not today, not tomorrow, but eventually.